types of joints. We have different types of joints. But before that, we need to talk about the skeleton and the function in the body. As we know that the brain and the spinal cord form the central nervous system, and they have been made up of very soft tissue. They could be easily damaged without a hard covering. So this is the reason why the skull, which is the bone on the head, and the rib cages, and also the spinal cord, which has the vertebra. This is a vertebra. It helps to cover the spinal cord. And the backbone, which is called the vertebra also, is made up of the 3 bones. And there is a hole in each vertebra through which the spinal cord runs from here directly to the brain. So these are gaps, and that's the reason why we call them a spinal cord. So it looks like a cord. So, but we should also know that the rib also protect the heart and the lungs and some other delicate parts of the body. That's the reason you see the rib this way. And the skull protects the brain. So all these things are some of the functions of the skeletal system in the body. And also we should know that the skeletal system is a system in conjunction with the muscular system allows you to move. There is no way a person will be able to move if he doesn't have all these the both systems in place. So we have some joints which are not movable, which are stagnant. Now these joints are held together by tough tissue and developed during the childhood. Examples are the cranium, the pelvis, and the vertebra. And that was an example of the cranium. And also we have some other ones which can move slightly, but not very much. The movement is needed, but not to a certain point. Like the vertebral column, it can move, but not the way, not as you think it does move. And also the individual vertebral organ are separated by cartilage. If you look deeply at this section, you would see that we have sections in here. You have 1, 2, 3. These are the sections in the vertebral column. Each of these sections has a cord that runs through them to the brain. And also, we should understand that the other type of bone of joints which we have is called the synovial. That bone can move very well. So the first one which is not movable is called the fibrous. The other one which does move is called the cartilaginous. And the other one, the last one which can move freely, is called the synovial. So these joints are also called synovial and allow movement to take place. There are 6 types of freely movable or synovial joints. So these are examples which we have one here, we have another one here. So let's talk about the types of the synovial joints which we have freely movable synovial joints. We can be divided into 6 groups depending upon the way they move. Now, looking at this picture here, you're going to see the first one, which is the ball and socket joint. The ball and socket joint is somewhere here on the space, and it helps you to move the shoulder. You can see the connection. There's a ball, and there's a socket here which the ball enters into. So this is the reason why it's been called the ball and socket joint. And also, we have another one here, in the hip. And that's why a person can move his hip in a 360 degree movement, because this is a socket here and there's a ball connected to the socket. And the next one is a hinge joint. The hinge joint functions like the hinge of a door. Like we know, for example, it makes you to move the body in one way and back to the normal place. It doesn't move in 360, neither does it move in in more than 180. So it means you can move it back and forth, back and forth. So we have another one here in the where you have the elbow. So these are places where you have the hinge joints and the pivot joints, the joints which you have in the neck region. And we have another one called the gliding joint. The gliding joint is most especially found in the fingers. And also we have the saddle joint, and we have the water saddle joint in the space. Not the same thing with the gliding, but they have a different location. I'm going to bring you different to. And the last one we have the condyloid joint, but most of the time is the joint you find in the ulna and the radii of the skeletal system. Now let's take a look at all these joints. The ball and socket joint, as I told you before, is formed in such a way that you have a socket which the ball enters into. And also it allows the greatest range of movement in the body. And in this type of joint, one end of the bone is shaped like a ball and fits into the hollow socket at the end of another one. Now it's also been held together by ligaments and tendons, which we're going to talk about later. Now this is the two main balls and socket joints, shoulder and hip joint. I showed it before, where you can see them here, and the next one is in the hip. So now the other one, which is called the hinge joint. The hinge joint functions like the hinge of the door. It opens and closes. Means that the way it does function is it allows extensive flexion and extension, bending and straightening with only a small amount of rotation. This joint is made by joining of two bone ends which have smooth surfaces. They are shaped to make against each other with minimum friction. In such, the main is there used to be a cushion in between them that will not allow them to slide over one another, so that it doesn't cause pain for the person when the movement is taking place. And we have another thing called synovial fluid that serves the purpose of lubricant between the two joints. The main of the lubricant is it doesn't allow friction to take place between between two objects which are in contact. Now another one is from ligaments, stop the bone from sliding off one another. We have a ligament which is what prevents the bone from sliding off of one another if the movement is taking place. So it's found in the hinge, it's found in the elbow, and also in the knee, like I showed you before. So this is an example of places you find them in the knee here and also in the elbow. And also, the next one is the pivot joint. The pivot joint allows only rotation. It doesn't allow movement moving forward and backward. It allows rotation. The joint, by the end of a bone, having a peg which fits into a ring. So there is a peg fitting into a ring formed by another bone. There is a pivot joint at the top of the spinal column. We have a pivot joint at the spinal column here. We have a pivot joint there. And it's between the axis and atlas bones of the neck. And this allows us to turn, raise, and lower our heads. This is crucial in controlling balance and maintaining awareness. So if a person is about to, let's say he's about to be hit with something, it turns back very swiftly. What makes that easy for him is because of the pivot joint. And this is where you find them in the body. Now the next one is the gliding joint. The gliding joints allow flexion and extension through a slight gliding motion between the ends of the small bones, such as hands and feet. These small bones can move over one another to increase the flexibility of the hands and the feet. And also it has strong ligament that links them together and stop them from moving too far away from one another. Now the gliding joint is found close to the wrist, and after the wrist you find the bone. This is the reason why you find people today, they can move their hand, they can twist the way they want to twist it, they can move it forward and glide over one another. So because of what? Because the bones are really functioning there. And sometimes if you have a fracture in it, the bones can separate from one another, and after some time they get connected to one another again. And also the next one is the saddle joint. The saddle joints, of course, where concave and convex surfaces meet. The saddle joints allow the movement of joints forward and backwards and right to the left. Example of saddle joints include the fingers and thumbs. We find them a lot in the fingers and thumbs, and this is the reason why people can break. They can make sounds with the thumbs and the fingers. They can break it easily. The reason is because of the joints which you have, which is called the saddle joint, because there is normally space between the. It's not very fixed together, and that allows you to move your fingers the way you want to do or move them. And next one is condyloid joints, is full of convex shapes, and one bone end fits into the full concave shape of another one. It allows movement in all directions, fiber, full rotations. And also, the main example of this is the one you find in the wrist. That's the reason why people today can move the wrist backward and forward, and it's really very important in you trying to maneuver your ways through accident or some other things. Now, just in a summary, we need to know what is really made up in the joint. The joint has a fluid called the synovial fluid. They have this fluid serves the purpose of lubricant, means it lubricates like an oil in a working engine. It enables all parts of the joints to move against each other smoothly without friction. And also we have this inside the synovial joint, we capsule which holds the fluid in place. So this is the synovial fluid. This is the cavity. There's a cavity here which has a fluid in it. Otherwise, the fluid will have to pour off the place. But the cavity holds the fluid in place and allows the fluid to get access to the bones to provide to prevent friction. And we also have the cartilages. The cartilage, we're going to talk about that later. Now the synovial membrane lies inside the capsule where the fluid is being produced. So we have a membrane inside the capsule where the fluid is being made. So we must understand that there should be a connective tissue between the bones and the muscles before movement can be possible. There are three types of connective tissues which we have. We have the cartilage, we have the ligament, we also have the tendons. The cartilage forms a cushion, it's like a foam, a cushion between two bones, in order that they don't rub against one another. So if you look at this place very well, this is the cartilage. It's from a cushion between this and between the cavity of the synovial fluid. So the reason why this is there is so that you don't feel friction between the two bones when they move. And many people today complain of pains in the joints because of the cushion being rubbed off because of frictional forces, and also because the synovial fluid is already finishing up in the joints. Another one is called the ligament. The ligaments are very strong string that holds bones together. This is mistake here. It holds, not hold. It holds the bone together. And the reason why that is because the bones are meant to be held together in a very tight way. Otherwise, the bone can move away from one another. And also we have the tendons. The tendons attach muscles to the bones and also to other muscles. So when there's a connection between the bone and the muscles, so the tendon connects muscles to muscles or muscles to the bones. So now this is a way to differentiate between the cartilage, the tendon, and the ligament. The cartilage is tough, though it's flexible, and at the end of the bone, you find that at the top of the cushion, the bone means is between two bones to prevent frictional forces between them or contact. That will also have the tendon. It attaches bone to the muscle and is very sturdy. It's not flexible. Meaning, when it says something is sturdy, means it's very rigid. That's another name you can use for sturdy. It means it's very rigid. It doesn't allow room for flexibility. So, and also, it's not elastic, and the size, it depends on the muscle. If the muscle is a very strong muscles, if the muscles are strong muscles which are used for very strong job or purposes, it's going to be big. It's going to be bigger the muscles which is doing a very simple job. And also just anchor. Anchor means to hold firmly and to a place. So now the ligament attaches bone to the bone. It's elastic. It stabilizes the movement of the bone, and also is made of many fibers, which is very strong. So these are the basic things you need to know about the joints. Now, before we continue, now here you have a movement. The skeletal and muscular system work together to move the body. Means a connection between the muscles and the bones make it easy for you to move. Movement is never possible if there is no connection between the muscles and the bones. And also, we need to know the muscles are attached to the bones. The pulling motion of the muscles makes it to move. People think the muscle pushes your body. No, the muscle doesn't have the capacity to push the bone, but it does pull it, and that's why movement is made easy. Now, movement occurs about a joint. A joint is a place where two or more bones meet. Now, this is an example of a joint here where these two bones meet. Now, the movement is being made easy because the connection of the muscle to the bone helps to pull the bone when you're trying to move your body. And also, the muscle are connected to the bones by tissues called the tendon, which I'm going to mention to you before. This is a tendon here. You can see the way it's so strong so that it doesn't allow it doesn't allow a breakage between the muscle and the bones. And also, we call something antagonistic muscle. They are called in pairs. Means these pairs are muscles which work against each other to allow you to move. An example is the bicep and the tricep. They are an example of an antagonistic muscle. The reason I'm saying this is when one relaxes, the other one contracts. And when one contracts, the other one relaxes. And as one muscle contracts, like you hear, one of them contracts here, the other muscle relaxes, and this swap their action. For example, the tricep relaxes and the bicep contracts when you move your hand up. When the forearm is being moved, raised up, the tricep will relax and the bicep contracts. And when you move it down, the triceps contracts and the bicep relaxes. And also, we should know that we can measure the forces in the skeleton using biomechanics. Biomechanics is the study of the forces acting on the body. We can use biomechanics to measure the size of the force that must apply to the bone. And so we don't need to talk about that for now. I think all we need is to talk about the muscles and the bones and about the way they help you to move. I think this is quite really helpful. Thanks for listening.